All right, this video is for number 12 for our calculus in class practice for differentiation. And I kind of made this so that we could use our graphing calculators, but this will be nice for you to be able to look at. So the first thing I'm going to have you do is graph y equals x squared. So I am graphing this, and I'm going to show you on the Inspire how we do this. So I'm just graphing this function, just as nice sketch for y equals x squared. And so this is my function. It says find the derivative of f of x equals x squared, graph the function and the derivative, and what do you find? So we're going to find the derivative using the definition. So below here, I'm going to do f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's going to be the limit as h approaches 0 of x plus h squared minus x squared all over h, now that I'm using the function. So f prime of x is going to be the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. And then I see that these can cancel. Thanks for playing. So this equals the limit as h approaches 0 of 2xh plus h squared all over h. And I still can't put my 0 in that, so I'm going to see if I can do some factoring, and I can. So now I have f prime of x. I'm going to factor out the h when I get there as a limit as h approaches 0 of h times 2x plus h all over h. And then I see, thanks for playing, these can cancel and make a 1. So this equals a limit as h approaches 0 of 2x plus h. And so now I'm going to plug in my 0 for h. So I get it to be 2x. So I know that f prime of x is 2x. So I know my original function. I know that when I graph this, and I know it's 2x, I know that it's going to kind of go through this point here, and then 2 times 1 is 2. It's going to kind of look like this. It's going to be a line. It's linear. So what did I notice about this? Well, I noticed that since when I started at f of x equals x squared, it had a power of 2, and I dropped down a power because f prime of x is 2x. So this has a power of 2, and it's a parabola or a quadratic. This is linear. So that's what I noticed, is I'm dropped down a power. I have one less turn in my graph. So what I did here was so that we could see this on the graphing calculator. And I also want to make sure you know how to do this again, is if I have this function here and I picked x squared and I want to actually graph the derivative, all you have to do is hit Control G to graph. And then what you're going to do is right next to the book, you're going to hit this, and you're going to see this here. It says d over d box times box, which is the derivative. And we're going to say it's of x, the derivative with respect to x, and I want to put the function. Now I could put x squared there, but if you hit variable and I can say, oh, it's f1 of x, I can actually say, I just want you to do the derivative of my original function. When I hit enter, even if I didn't know what it was, as you can see, it graphed the derivative. Even though I know it's y equals 2x, you don't have to know exactly what it is. You can actually graph the derivative, and I just wanted to remind you about that. Okay, so now I'm going to go back to my in-class practice, and I gave you derivative lab 1 to do, and I had you go all the way up to 40. So I'm going to actually do the last two with you just to make sure, because they get a little tricky. Well, this first one here, I want to show you. It says the power rule practice lab. This is number 39 and 40. It says find the derivative using the power rule where a, b, and c are constants. So I'm actually going to do h of x with actual numbers in it, because a constant is a number. So I got 2x plus 3 over 3. So if I were asking you to do the derivative for that, I'm going to have to rewrite that and get it all ready. So I'm going to divide each piece by the 3. And when I do 3 divided by 3, I get a 1. So that if I'm actually finding the derivative of this using the power rule, since there's a 1 here, I'm using Christmas colors, 1 times 2/3 is 2/3. If I subtract 1, that's to the 0 power, so that's just 2/3. And the derivative of a constant, or 1, is 0. So that is what h prime of x is. Now, why did I do that first before I did it with all letters? Because it's the same type of thing. So here's h of x. And I'm going to split it up because a, b, and c are constants. So I have a over c x plus b over c. So now when I go to do the derivative, I'm going to do h prime of x. This has a power of 1. 1 times a over c is a over c. Subtract 1, that's to the 0 power, so that's a 1. And the derivative of a constant is 0. So h prime of x is going to be a over c. So that's number 39. Number 40, I'm actually going to do it in little baby steps, just because most of this is what you're doing here is algebra. The calculus is just doing the power rule. So the first thing I look at this and say, I can like do some distributing here. So I have radical t plus t radical t all over t squared. And then I'm going to look at that and say, I can write that again. I can write that using powers. So when I do, I know radical t is t to the 1/2 plus t times t to the 1/2 all over t squared. And then I see, okay, I'm getting there. I'm looking at, I can multiply these two. And if I'm multiplying and they have the same base, I can add them. So in your head, I would actually think of this as a 2 over 2. So I have g of t, I'm getting there, is t to the 1/2 plus, if I have the same base and I'm multiplying, I'm adding it. So a half plus 2 over 2 is t to the 3 over 2 all over t squared. Now I'm going to kind of employ what I showed you earlier, that if I'm dividing by a binomial, then I can split it up by dividing each side by that. So that's going to be t to the 1/2 divided by t to the 1/2. Oh, excuse me, that's t squared. I don't know why I changed that. It's a t squared. I'm sorry. Let's go back. So this is a t squared. Divided by t squared, okay, plus t to the 3/2 divided by t squared. I'm getting there, folks. So g of t equals, so if I have the same base and I have exponents, I'm going to subtract the exponents. Again, think of this 2 with a denominator of 2, so that would be 4 over 2. 1 over 2, or 1/2, minus 4 over 2 is t to the negative 3/2 because you're subtracting. Plus, think of this again. This is 3/2 minus 4 over 2, so that's just going to be t to the negative 1/2. I just want you to notice I have not once said g prime of anything. All I've done is just the algebra. So what we're going to do here is actually just start doing the derivative. And when I do the derivative, this is when the calculus starts, right here. This is the only one with the calculus. So the first thing I'm going to do is do the power rule. So 3 negative 3/2 times negative 3/2 t, and I'm going to subtract a 2 over 2 because I have to subtract 1, so it's going to be negative 5/2. Now I'm going to do the derivative there, so it's going to be minus 1/2 t, and I'm going to subtract 2 over 2 because I subtract 1, minus 3/2. That is the derivative. That is the only calculus I've done. Now I'm just going to rewrite it because I want to get you guys practice doing that. So it's going to be negative 3 over 2, and that's going to be radical t to the 5th. Remember your flower power, minus 1 over 2 radical t cubed, because you're going to bring that down. And these two are basically the same. I'm just having you rewrite it. So that's all I've got for this video. I just wanted to make sure that you're comfortable doing this, and thank you very much.